Welcome to qnawire.
Okay, so we know the velocity can be equal to Mach number times square root kRt. So when the Mach number is given as 0.8 and the specific heat ratio for the air is 1.4, we know the gas constant for the air is 0.287 kilojoule per kilogram times Kelvin, and the temperature is 100 degrees Celsius, which is 373 Kelvin. So now let's plug in back to the equation to determine the velocity. So the velocity is equal to 0.8 times square root 1.4, and then times 0.287 kilojoule per kilogram times Kelvin, and then multiply by 373 Kelvin. And remember, we need to convert to the meter square per second square, since the answer is having a units meter square per second square. So therefore, let's do it. So it's about 1,000 meter square per second square over 1 kilojoule per kilograms. And this will give us the velocity is about 309.7 meter per second. So now let's take a look at the stagnation pressure. So we know stagnation pressure, which is P0 here, can be equal to P times 1 plus K minus 1 over 2 times MA squared, and then to the power of K over K minus 1. So we know the pressure is given as 200 kilopascal. So therefore, let's plug in back to the equation to determine the stagnation pressure, which is equal to 200 kilopascal, and then times 1 plus K minus 1. Oh, K minus 1 is, let me see, 1.4 minus 1 divided by 2, and then times MA squared, which is 0.8 to the power 2, and then to the power of 1.4 over 1.4 minus 1. And this will give us the stagnation pressure is about 304.87 kilopascal. Okay, so now let's take a look at the stagnation temperature. So we have T0 is equal to T times 1 plus K minus 1 over 2 times MA squared. So we know the temperature is given as 373 Kelvin, which is 100 degrees Celsius. So now let's plug in back to the equation to determine the stagnation temperature, which is equal to 373 Kelvin, and then multiply by 1 plus 1.4 minus 1 over 2, and then times 0.8 to the power 2. And this will give us the stagnation temperature is about 420.744 Kelvin. Okay, so now let's take a look at the stagnation density of the air. So we have rho 0 is equal to rho times 1 plus K minus 1 over 2 times MA squared to the power of 1 over K minus 1. So we know density can be expressed as P over RT. So we have rho 0 is equal to P over RT times 1 plus K minus 1 over 2 times MA squared to the power of 1 over K minus 1. So we know the gas constant is 0.287 kilojoule per kilogram times Kelvin. So now let's plug in back to the equation to determine the stagnation density of the air, which is equal to 200 kilopascal divided by 0.287 kilojoule per kilogram times Kelvin, and then times the temperature, which is 373 Kelvin, and then times 1 plus 1.4 minus 1 divided by 2, and then times 0.8 squared to the power of 1 over K minus 1, which is 1 over 1.4 minus 1. And this will give us the stagnation density of the air is about 2.525 kilogram per meter cube. And these are the answers for this question.